Good morning, ni hao. Thank you for Inspur for sharing the stage with me. I want to talk to you about, as soon as my slide comes up. Thank you. So I want to talk to you a little bit about cloud and the role that OCP plays in the cloud. I want to talk to you about some of the innovations that Intel is doing and the projects that we are involved in OCP. I'll talk to you briefly about edge computing that's becoming very important, and hopefully that will cover my 15 minutes. There is a surge of data, and that's requiring larger and larger cloud infrastructure capacity. In fact, in the next 4 years, it's expected that the capacity that the cloud needs is going to grow by 2x. This means we need to have high density compute storage and networking in place. And what's motivating that? It's motivated by digital retail, digital advertising, casual stores, digital video, and cloud services. Together, that's about $6 billion, or I guess 40 trillion yuan, of infrastructure that is coming into play. So in order for cloud, we need just solutions, not just hardware. And this is where the partnership with OCP comes in, right? So we need platform, and platforms are served by server, storage, and networking track in OCP. We need platform security, and there is a security project that we participate in OCP to drive the security needs of the platform. And we need firmware, and there is an open system firmware project that we participate and contribute in OCP. And manageability, managing all these things is key for both data center infrastructure and even more important for edge infrastructure. And there is a hardware management track at OCP. And of course, rack and the data center facilities management is important as well. And there is a rack and power track in OCP. And at the data center level, crack and power and cooling at that data center level is at the data center facility. Once again, Intel is an active participant in those things. So in our minds, OCP is really well positioned to satisfy all the requirements of the cloud. As I mentioned, there is a need for this high density cloud optimized platform. So we have been investing in essentially doing reference design for the next generation of cloud infrastructure to satisfy the demand of this 2x the capacity that's going to be at our doors pretty soon. And one of the things that we've been looking at is a high core count in 2U platform, and that gives you the ability to save costs by consolidation of your capital, and also it gives you better operational efficiency because you're managing one server instead of two. And we are targeting this type of solution at infrastructure as a service, which is primarily cloud. And our goal is number of VMs in the platform, and also to offset the efficiencies in there. And we provide all the, and I'll describe it in a little bit more detail. We provide all the OCP ingredients. And we have, and then this is not just Intel. We have partnered with Tencent in close collaboration. And they agree and support this vision that Intel has for a high-density, cloud-optimized 4-socket platform. And what does that platform look like? Inspur referred to it a little bit ago. So the first platform that complies to the Intel's vision for this high-density, cloud-optimized platform is from Inspur. And it's a 4-socket platform in 2U. It's a 450 by 780 millimeter 4-socket Xeon platform. With this platform, you can do 192 VMs, 192 PCIe lanes, and 1.5 terabytes of memory in a 2U form factor. And added to that, it has access to 24 drives, and there could be a combination of SAS, SATA, and NVMe. And the supply lines are forming in there. This is the design that we have jointly contributed with Inspur to OCP. And we are OCP for recognition, and we are in the final stages of that recognition from our mind. So we view this as a game changer because to get this type of density, and in this 2U form factor that's extremely cloud optimized. And you can see there are other partners involved here that we work with as well. But on the one that's being contributed as a design file, you can see that all the cloud requirements, like the power supply in the rear, front loadable drives, service accessible drive infrastructure, OCP 2.0 and 3.0 NICs, all of them are present here. Now, I want to switch gear and talk to you about some of the other innovations that Intel is bringing in partnership with OCP as well. I don't have a lot of time, so I'm going to pick and choose on a couple of things that we're doing in OCP. So this is a project that we plan as a case study in the open system firmware. We actively participate in open system firmware, and last year at the OCP session, I opened up the Perley Skylake platform package, and thereby allowing for open firmware to be possible. And this is in the same vein. One of the biggest problems we have in server platforms, especially cloud server platforms, is performance variance. And the performance variance is caused by an interrupt called SMI that many cloud vendors and even enterprise vendors use to manage their platform for various reasons. And these interrupts basically introduce variance in the platform, because when they happen, they are globally synchronizing. There is no work that makes progress. So one of the things we have done is and many times the platform firmware uses these to do things that are not otherwise possible from an OS context. And what we have done is, rather than use SMI, we have tried to move this into a new mechanism called what we call PRM, Platform Runtime Mechanism. What it does is moves the things that people used to do in the BIOS and SMI up into OS layer. And what this allows is now, when you run an SMI, the code is not visible to you. So it's very hard for you to trust a code that you can't see that's doing something. So you can read it, you can audit it, but you cannot change it. So that gives you all the privileges that you're used to having with SMI, but gives you at the same time it takes away the performance variance, so you have good performance in your system. As I mentioned, this is a case study. The second project I wanted to talk to you about is a data center cooling, data center power prediction. Today, if you look at the chart that's on the screen, it's basically showing you data center power. And if you had kept on the line from the early 2000s, it would be practically impossible for us to supply power to all the data centers that are in the world. And what has happened is that a combination of hyperscale principles and improved management and best practices together have essentially allowed us to keep our power consumption for the same amount of compute low, right? So one of the things that they do here is essentially they essentially have a feedback mechanism. So you know the utilization. Based on that, you call your data center facilities to increase your cooling, and it's a closed loop. But the problem with the closed loop mechanism is that it doesn't take it's reactive. It happens after the fact. After I have a need, you're going to react. And all these things have a hysteresis, meaning they lag a little bit. So the better mechanism, and the one that we're working on in partnership with our China cloud customers, is a predictive mechanism where we know the patterns that exist. So this is actually a project that we did with Baidu. We know the patterns in our data centers, in a cloud data center. On the basis of that, we are going to essentially predict what the power requirement and therefore the cooling requirement is going to be, and feed that back so you're one step ahead of where the system is going to be in a few hours. And this is a project that we are planning to contribute into the data center facilities portion of it. And so switching gears from cloud focused to edge. Edge is really an emerging application. And why did Edge come into being? Edge came into being because of the data growth, and it was impossible to move all that data back into the public cloud data centers and operate on them from a latency and from a bandwidth standpoint. So the logical thing is to essentially move some of the services down into the edge. So in order for edge to be possible, we need the edge platform. And again, we have all the ingredients in this space. And you need to have the solutions in that space. And put it together, you essentially have this cloud platform that can now act as an edge and also feed into the data center when it needs to for its data, right? So CDNs, MEC, they're all in this space. This is a great opportunity. So while we don't have any active projects going on, this is a great opportunity for the CSPs, the audience here, and Intel to work together with OCP on edge platforms and edge architecture. So what are the edge requirements? So they want solutions, right? You want one platform, because if you're going to deploy this in retail, you're not going to give them a platform and tell them to go buy software from somewhere and rest of the service from somebody. It needs to be a fully integrated solution. They want remote management because they don't have the same IT professionals managing an edge. It's probably sitting in a retail store somewhere. And ease of maintenance for the same reason, because the person that's touching that edge server is an unskilled person typically. And again, because it's remote, you want things to fail in place and be failure resilient, meaning I don't want a single failure to basically crash the system that I can no longer go have productive value out of my system. So the kind of innovations that we are and we plan to continue to bring is, of course, the hardware ingredients in our CPUs, FPGAs, inference accelerators, and so on. And we have open frameworks like OpenVINO. We lead the manageability in OCP for lights out remote management, which is very critical, even more critical in the edge than it is for the cloud data center. And we need open firmware and firmware complexity reduction. So like PRM that I mentioned is an exercise in reducing the complexity of the firmware, so these things do not become a point of failure in your edge environment. And firmware also needs to be resilient, which means you should not have any security vulnerabilities in your firmware, right? This is the open security project that we work with OCP on, because in an edge, your platform is a lot more vulnerable than it would be in a data center that's protected by, four walls and security guards, I guess. And rack and power management, right? So this is basically most of the edges in colo or in a retail end location. So you don't really have access to a lot of power, and so you need to essentially make sure that you have good rack and power management. And again, we also play an active role in the OCP's rack and power management track to essentially not only serve the cloud customers, but also the emerging edge needs in this space. So there is a lot of projects that we work on. So the one that we are here for and we are most excited about is the contribution to OCP from Intel and Inspur, which is our latest on the high-density 4-socket cloud-optimized platform called Crane Mountain. And so I mentioned to you about the data center cooling. We plan to contribute a white paper that builds on the redfish profile that OCP has adopted to the DCF project. In addition to that, in the open OCP firmware project, we actually are planning to do a case study on platform runtime mechanism. And we're also looking at, in terms of opening up firmware, we're also looking at multi-socket firmware support package. It's called FSP. This allows you to build your own boot solution as opposed to rely on boot mechanism or some third-party something in that. And you're also active. We know that storage distribution is growing around, and things are moving to NVMe-based solutions from hard drives. There is so we are working on tested configurations. We are wanting to concentrate on storage distribution for many. It used to be when it was based on RDMA. Now we have a solution that's based on TCP/IP as well that serves the needs of TLC and QLC based NAND solutions for the cloud environment. So these are a few of the many projects that we're involved with the cloud community and specifically with OCP. So my call to action from all of you is to take advantage of the innovations and contributions that we bring to OCP. And please collaborate with us. And if there are any new ideas you have on cloud innovations, we would be very eager to talk to you and collaborate with you. And also on behalf of OCP and folks like Bill, I would like to invite you to participate more. It was wonderful to be here in Beijing for the first OCP Beijing Day, and we look forward to more opportunities like this in the future. Thank you very much. Thank you.